Welcome to Algebra for Artificial Intelligence, a practical guide designed for anyone eager to understand the math that powers modern AI. At its core, AI is all about mathematical relationships, and algebra is the language that lets us express these connections. Whether you're building a simple model or a complex neural network, algebra helps you represent data, express relationships between variables, optimize decisions, and learn from errors. If you can grasp the basics of algebra, you're already thinking like an AI system. In this video, we'll break down the essential algebraic concepts you need, focusing only on what's truly useful for AI, not abstract school math. Let's dive in and see how algebra forms the foundation of every AI model. In algebra, a variable is simply a symbol for an unknown or changeable value. In AI, variables are everywhere. They might represent an age, a price, a pixel value, or even a stock price. For example, in the equation y equals 2x plus 3, x could be any input and y is the output, such as a prediction or classification result. The most basic AI model, like a linear predictor, uses variables to connect inputs and outputs. Prediction equals weight times input plus bias. This single equation is the backbone of machine learning. By understanding variables, you can see how AI models learn from data and make predictions. Next, we'll see how these variables come together in linear equations, which are fundamental for AI. Linear equations are at the heart of AI modeling. The classic form is y equals mx plus b, where is your input, m is the weight showing importance, b is the bias and offset, and y is the output. In AI, this is known as linear regression, one of the first models you'll encounter. For example, predicting house prices might look like house price equals 2,000 times size plus 10,000. Here, the AI learns the best values for m and b from data. This simple structure allows AI to make predictions, classify data, and even start learning from errors. Understanding linear equations means you're ready to tackle more complex models, including those with multiple variables and features. As AI models grow, they rarely work with just one variable. Instead, they use vectors, lists of numbers representing features like age, income, or clicks. For example, a vector might look like x equals x1, x2, x3, and AI combines these with weights using a dot product. Output equals w1x1, w2x2 plus w3x3. This operation is the mathematical core of neural networks and classification algorithms. When dealing with large datasets, AI uses matrices, tables of numbers where rows are data samples and columns are features. Matrices allow AI to process thousands or even millions of data points at once, making large-scale learning possible. Mastering vectors and matrices is key to understanding how AI handles real-world data. AI learns by minimizing errors. The simplest error is the difference between actual and predicted values. Error actual minus predicted. Often AI uses squared error. Error equals actual minus predicted 2, which penalizes large mistakes and smooths optimization. To improve, AI adjusts its weights using optimization techniques like gradient descent. The core update rule is new weight equals old weight minus learning rate times error. This iterative adjustment is what allows neural networks and other models to learn from data and get better over time. By understanding these algebraic operations, addition, subtraction, multiplication, and division, you unlock the logic behind AI's learning process. To master practical AI, you don't need advanced algebra, just a solid grasp of the basics. Focus on variables, linear equations, functions, vectors, matrices, and error calculation. These concepts are enough to understand 95% of real-world AI applications. Algebra is the first step on the AI learning roadmap, followed by statistics, machine learning, and deep learning. Remember, every AI system, from simple classifiers to deep neural networks, relies on algebraic thinking. Don't fear algebra, embrace it as a practical tool. Always ask yourself, what does this equation represent in reality? With this mindset, you're well on your way to AI mastery.